Question number 19. The endpoints of a line segment are C, and the coordinates of C are k, 3, and D is 11, k. And we're asked to find the value of k if the slope of line segment CD is 1/3. So we need the slope formula for this, so that's why in my solution I have m equals y2 minus y1 over x2 minus x1. Now let's identify what the x's and y's are in these 2 points. I'm going to refer to my C point as the first point, so I'm going to call that x1, y1, and oh, that's supposed to be a 1. Let's fix that. That doesn't look like a 1. And 11, k is going to be my second point, so that'd be x2 and y2. So in my slope formula, y2 minus y1, y2 is the k, and y1 is the 3. So k minus 3 in the numerator. x2 minus x1, x2 is the 11, x1 is the k, so 11 minus k in the denominator. And we're told the slope is 1/3, so 1/3 goes in place of m. Now we're trying to solve for k here, and notice we have k in 2 different places. So I'm going to do something called cross multiplying to get rid of the fraction parts here, and eventually isolate for k. So cross multiplying says the product of the 2 things and the diagonal are the same. So 1 times the 11 minus k here would equal the product of 3 and the k minus 3. And that's exactly what I have written in the next line here. 1 times 11 minus k, which is what's right here, equals 3 times the k minus 3, which is what we have over here. Now, the next thing I would do is expand or distribute the 1 into these brackets here, and the 3 into these. And so it looks like this. 1 times 11 is 11. 1 times negative k is negative k. 3 times k is 3k, and 3 times negative 3 is negative 9. Now what I want to do is get the k terms, the variables on one side, and the numbers or constants on the other. So I'm going to bring all my k's to the left. And so I'm going to bring the 3k over here, and so that's why it's negative k minus 3k. And I'm going to bring the 11 over here to the right, and it's a positive 11 on the left, so it'll be a minus 11 on the right. Now another way to think of doing that is, you see the 3k is a positive, so I'm going to subtract 3k from both sides. And I want to get rid of that 11 from the left side, so it's positive, so I will take 11 away from both sides. And so notice that these are opposites, so they add to 0. These are opposites, so they add to 0. And what I have left on the left side is negative k minus 3k. And on the right I have negative 9 subtract 11. And so negative k minus 3k would be negative 4k, same as adding a negative 1k and a negative 3k adds to negative 4k. And negative 9 minus 11 would be negative 20. And so I want to isolate for k now, so we need to get rid of this negative 4. It's multiplied by k, so to undo multiplying we divide. So we divide both sides by that negative 4, that negative 20 included. And the whole purpose of that on the left here is so those negative 4's divide out. And so k on the left equals negative 20 divided by negative 4 is positive 5, which up here is answer B for question 19.